Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, y'all, we are going to be talking about hypothesis testing, okay? We're going to cover a lot of terminology about what it is and how do you use it. All right, so what is a hypothesis? A hypothesis is a statement regarding a characteristic of one or more populations, okay? And specifically, hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. All right. So a hypothesis, just to go back, is a statement regarding a specific characteristic of one or more populations, and then testing is when you do some type of procedures based on the sample evidence, so that's the evidence we get from the sample, and some probabilities used to test the statement, the hypothesis, regarding that characteristic. So steps in hypothesis testing. So we're going to be making a hypothesis about some type of parameter, such as the proportion, the mean, or the standard deviation. And so in order to do that, we first have to make a statement regarding the nature of the population. So what it is we think the proportion is, or what we think the mean is, or what we think the standard deviation is. Then we have to collect evidence, and this is data that we get from our sample, to test the statement, and then we analyze the data to assess the plausibility of the statement. So those are the three steps that you take in hypothesis testing. Now, you can have two different types of hypotheses. The first one is the null hypothesis, and we use this little subscript of 0 on the H, and this reads H naught. All right, H naught, and this is a statement to be tested, and it means a statement of no change, no effect, or no difference, and it is assumed true until evidence indicates otherwise. So it's kind of like innocent until proven guilty. That's what the null hypothesis is like. It's a statement of no change, okay? Now, the other hypothesis is the alternative hypothesis, which we use a subscript of 1 on the H to denote. So this reads H1, and this is a statement that we are trying to find evidence to support, all right? So it's different than the null hypothesis in some way, and we're going to look at the different ways it could be different. All right, so these are your possible hypotheses. So first, you have equal hypothesis versus not equal hypothesis. This is called a two-tailed test. Your null hypothesis, which is H naught, remember, that's the hypothesis of no change. So we have some parameter. Our parameter is, remember, describing the population. This is either your proportion, your mean, your standard deviation, something like that. It's equal to some value. So your null hypothesis is that your parameter equals some specific value. And then the alternative hypothesis would be that the parameter does not equal that value. All right, so your null hypothesis is always going to be a statement of equality. So that's called a two-tailed test. Now, you can also have what's called a left-tailed test, and this is when your null hypothesis is that the parameter equals some value. That's always going to be your null hypothesis, but your alternative hypothesis is going to change. And in the left-tailed test, your alternative hypothesis is that the parameter is less than some value. And then vice versa, you can have a right-tailed test. Your null hypothesis, again, is a statement of no change, so your parameter equals some value. But your alternative hypothesis this time is that your parameter is bigger than some value. And when bigger than, it goes to the right. So that is a right-tailed test. Less than goes to the left, so that's a left-tailed test. So here's an example. Determine the null and alternative hypotheses for the following. And then we're going to state whether the test is two-tailed, left-tailed, or right-tailed. All right, so I'm going to give you some examples, and we're going to go through these. So here's the first one. The Medco pharmaceutical company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the Food and Drug Administration wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. All right, so first of all, we have to figure out which population parameter is being tested here. And this will be proportion, because we're trying to figure out the proportion of students who are taking antibiotics and that are a specific antibiotic and they're experiencing side effects or experiencing headaches as a side effect. So that would be a proportion. All right, so there is a claim that 2% of children taking this new antibiotic experience headaches as a side effect, but the researcher wants to test to see if more than 2% is taking that, is experiencing that side effect, okay? So what we have is a null hypothesis of P, that's proportion, equal to 0.02. So equal to some value. In this case, it'll be equal to 0.02 because that's 2%, all right? So then our alternative hypothesis would be the fact that P is more than 2% or more than 0.02. And so this is what we will be testing: a null hypothesis of P equal to 0.02 and an alternative hypothesis of P greater than 0.02. Now, put another way, in words, you can also say that is, for H naught, your null hypothesis, the proportion of individuals taking the new drugs who experience a headache as a side effect is 0.02. And then for the alternative hypothesis in words, you will say the proportion of individuals taking the new drugs who experience a headache as a side effect is more than 0.02. And here are your hypotheses, which I had just written out. All right, here's another example. The Blue Book price of a used 3-year-old Chevy Corvette Z06 is $59,083. Grant wonders if the mean price of a used 3-year-old Chevy Corvette Z06 in the Miami metropolitan area is different from $59,083. All right. So what are we testing here? Which population parameter are we testing here? It is the mean. You see it right here. If the mean price. So for our null hypothesis H naught, it's going to be the fact that the population mean is equal to 59,083. That's the statement of no change. And then our alternative hypothesis would be that the mean population is not equal to 59,083. All right. Now it says no, that it is that if the mean price of a used Corvette in the Miami metropolitan area is different from 59,000. So different from means that it's not equal to 59,083. So in this case, this would be a two-tailed test, which I forgot to mention in the last one what test that was. But this one would be a two-tailed test because it's a alternative hypothesis of not equal to. On the last one where we had, let me go back, where this one, the alternative hypothesis was greater than, because it was greater than, this was a right-tailed test, okay? That's a right-tailed test. Now this one, in words, you would say that the mean price of a 3-year-old Corvette Z06 in Miami is no different from the Blue Book price, $59,083. So the mean is equal to that. But for the alternative hypothesis, the mean price of a 3-year-old Corvette Z06 in Miami is different from the Blue Book price of $59,083. And so this is in words, and this is symbolically what your null and alternative hypothesis will be. Again, that's a two-tailed test. All right. And then one more example is the standard deviation of the contents in a 64-ounce bottle of detergent using an old filling machine is 0.23 ounces. The manufacturer wants to know if a new filling machine has less variability. All right. So in this case, the population parameter that we're testing is standard deviation, which you can see right here. So we're testing the population standard deviation. So our null hypothesis is going to be our sigma equal to 0.23. So that is that the standard deviation of the population is 0.23. And then our alternative hypothesis is that we want to know if the filling machine has less variability. So would our standard deviation be less than 0.23? That would be our alternative hypothesis. Since it is less than, that would be considered a left-tailed test, okay? That would be a left-tailed test. Now, in words, what that would look like is our null hypothesis would say the standard deviation amount in the bottles is no different from the old machine, which is 0.23 ounces. And then our alternative hypothesis in words would say the standard deviation amount in the bottles is less than the old machine of 0.23 ounces. And so this is how you identify your null and your alternative hypotheses. And I believe that is all I'm going to talk about in this video. Yes, I just wanted to identify the terminology for the hypothesis testing, the null hypothesis, and the alternative hypothesis, the right tail test, left tail test, and two tail test. Now, in the next video, we're going to talk more about the different possibilities of your hypothesis testing and what results from that. So thank you for watching this video. Let me know if you have any questions. If not, I will see you all in the next video.